half of magnitude of A cross B represents area of a triangle, and magnitude of A cross B represents the area of the parallelogram. Let us take the cross product of AB cross BC, where these represents the sides of the triangle. This is I, J, K, 1, 2, 3, minus 1, 2, 0. If we take minus 2 as a common factor, then here I'll get I minus 2j plus k. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. Here in this session, we are going to study the applications of vector product or cross product. Some of the important geometrical application of vector product are that if vector A and vector B represents the adjacent sides of a triangle, then the area of the triangle is equal to half of magnitude of vector A cross vector B. We know that vector A cross B represents a vector. So if we need to calculate the magnitude, then we need to find out under the modulus of A cross B. So here, if in such case, we have a triangle with three vectors. Let this be vector A, vector B, and this is some vector C. Now, suppose if A and B represents any two sides of the triangle with some inclination between them, obviously, then if we take the cross product of vector A and vector B, then the area of the triangle can be given in the form half of magnitude of A cross B. Similarly, if A and B are the adjacent sides of a parallelogram. So let us consider this as vector A and this as vector B. Now assume that it represents a parallelogram. So these are the sides of the parallelogram with some again inclination of theta. If vector A and vector B represents the sides of the parallelogram, then the area of the parallelogram can be calculated using the vector product by taking its magnitude. So therefore, half of magnitude of A cross B represents area of a triangle, and magnitude of A cross B represents the area of the parallelogram. Find the area of the parallelogram whose adjacent sides are given by the vectors vector A 3i plus j plus 4k and vector B I minus j plus k. So we know that A cross B can be represented in the determinant form as I, j, k in the first row, scalar components of vector A in the second row, and scalar components of vector B in the last row. So therefore it is I, j, k, 3, 1, 4, 1, minus 1, 1. So if we take the determinant of this, then it is 1 minus 4 becomes plus 4, minus j, 3 ones are 3, minus 4 ones are 4, plus k. We have 3 into minus 1 minus 3 and minus 1. So this is 5i minus 1 of minus plus j minus 3 minus 1 minus 4k. So now this is our vector A cross B. Now to find the area of a parallelogram, let's take the magnitude of A cross B. So that is equal to square root of 5 square plus 1 square plus minus 4 whole square. So 25 plus 1, 26. Then 16 is 16 plus 26 root 42. Since we are writing the area, it is always equal to square units. Next question. Find the area of the parallelogram whose adjacent sides are given by the vectors vector A equals I minus j plus 3k and vector B equals 2i minus 7j plus k. So here vector A cross B is equal to I, j, k. 1 minus 1, 3. 2 minus 7, 1. Let's expand this determinant. So we have minus 1 minus 21, which becomes plus 21, minus j. So 1 into 1, 1 minus 2 into 3, 6, plus k. 1 into minus 7 minus 2 into minus 1 minus 2, which becomes plus 2. So we have here 21 minus 1, 20i, minus 5, which becomes plus 5j, and here we have minus 5k. So now magnitude of A cross B represents the area of the parallelogram. So hence this is 20 square plus 5 square plus minus 5 whole square under the square root. So this is 450. So this can also be written as a square root of 9 into 50, which is 9 5s are 45. So 50 can also be written as 25 into 2. So if we take the square root outside, it is 3 into 5 root 2. So the value is 15 root 2. So therefore, the given required area of the parallelogram with the vectors A and B is 15 root 2 square units. Next question. Find the area of the triangle with vertices A 1, 1, 2 and B 2, 3, 5 and C 1, 5, 5. If I consider this as vertices A, B and C. So we need 1, 1, 2, that is side AB. B is 2, 3, 5 and also we need side BC. So C is 1, 5, 5. Since points are given, we need the position vector. So if I need vector AB, then it is obviously OB minus OA. So therefore, I'll get this in the form of 2 minus 1, 1, I. Again 3 minus 1 plus 2j, 5 minus 2 plus 3k. Now I need vector BC, the side BC, which can be written as OC minus OB. This in vector form can be written as 1 minus 2 minus 1i. Next 5 minus 3 2j. Next 5 minus 5 0. So now let us take the cross product of AB cross BC, where these represents the sides of the triangle. This is I, J, K, 1, 2, 3, minus 1, 2, 0. So if we expand this, I into 0 minus 6 minus j into 0 plus 3 plus k into 2 plus 2. So that is equal to minus 6i minus 3j and plus 4k. Now if we take the magnitude of vector AB cross vector BC, then that is equal to minus 6 whole square plus minus 3 whole square plus 4 square. So this is equal to root 61. Now since we need the area of a triangle ABC, this is half of magnitude A cross B. So that is equal to root 61 by 2 square units. Next question is, find a unit vector perpendicular to each of the vector A plus B and A minus B, where A is ijk and B is I plus 2j plus 3k. So we need to find the perpendicular vector to vector A plus B and vector A minus B. So first let us find out what is vector A plus B. So vector A plus B is 1 plus 1, 2i, j plus 2j, 3j, k plus 3k, 4k. And vector A minus B is equal to I minus I 0, j minus 2j is minus j, and k minus 3k is minus 2k. So since we need the vector which is perpendicular to these two vectors, so we need to take the cross product of these vector. So the cross product of these vector is vector A plus B cross vector A minus B. So let this be vector C. So this vector is the vector which is perpendicular to these vector. So we need to find out the unit vector of vector C. So first let us find out the cross product of vector C, that is I, j, k. Now the scalar components are 2, 3, 4. So here 0, minus 1, minus 2. Let's expand the determinant. We'll get this as I into minus 6 plus 4 minus j into, so minus 4 minus 0 plus k into minus 2 minus 0. So this is equal to minus 2i, minus into minus becomes plus 4j, and minus 2k. Now we have vector C as minus 2i plus 4j minus 2k. So vector C is the vector which is perpendicular to both a plus b and a minus b. But we need the unit vector perpendicular to this vector. So therefore, we need C cap. So C cap is vector C by its magnitude. Now let's write vector C here. So vector C is minus 2i plus 4j minus 2k. And magnitude of vector C is minus 2 whole square plus 4 square plus minus 2 whole square under the square root. So here, if we take minus 2 as a common factor, then here I'll get I minus 2j plus k. And here, this is equal to root 32, which can be written as 4 root 2. Because this is 16 2s are 32, so 4 root 2. So whole divided by 4 root 2. So here if we cancel this, vector C cap or the unit vector can be written as minus 1 by root 2 I minus 2j plus k. So this is the unit vector perpendicular to both the vectors a plus b as well as a minus b. Next question is, find the sine angle between the vectors I plus 2j plus 3k and 3i plus 2j plus 6k. So we know that sine theta is magnitude of a cross b divided by magnitude of a, magnitude of b. So first let us find out what is magnitude of a. So magnitude of a is square root of 1 square plus 2 square plus 3 square. That is equal to root 14. Magnitude of b is equal to square root of 3 square plus 2 square plus 6 square. That is equal to root 49, which can be written as 7. Next, we need to find out a cross b. So therefore, a cross b is equal to I, j, k. Scalar components of a is 1, 2, 3. Scalar components of b is 3, 2, 6. Let us expand this in the form of a determinant. Then that is 12 minus 3 2s are 6 minus j into 1 6 are 6 minus 3 3s are 9 plus k into 1 2s are 2 minus 3 2s are 6. So this is equal to 6i. Now here plus 3j. And here we have minus 4k. So this is our a cross b. We need magnitude of a cross b. So that is equal to 6 square plus 3 square plus minus 4 whole square under the square root, which is equal to root 61. Now if we substitute in this formula, then sine theta will be equal to root 61 whole divided by, so magnitude of a is root 14 and magnitude of b is 7. So this implies theta is equal to sine inverse of root 61 whole divided by 7 root 14. So this is the angle between the given vectors. So this is all about the chapter vector algebra. I'll meet you in the next session with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.